derivative rules for you guys. Hi guys. Good to see you. And good to see you. We're just taking notes, and like just keep this with your book. All right. So these are just derivative rules. And I think there's going to be seven things, so utilize the front and back. So the first one is if you had f of x is equal to 5x squared plus 10x. Sometimes they call this the addition rule. And the derivative is pretty simple. We've already done this. You just bring this down front, subtract 1. There's a 1 out front, bring that down front, and then minus 1. Then you would get x to the 0. X to the 0 is 1. That's why it doesn't go. The subtraction rule works the exact same way. It's just you make sure you keep the subtraction sign in there. So that's the first thing that we kind of covered. Agree? And we started talking a little bit of the quotient rule. We'll move on to something that they call the power rule. Can I move off the screen? No? Okay. So the power rule is like if you have a quantity, like something in parentheses, and you have an exponent outside of it. You guys ready? Okay. So this is, they call it the power rule. So this would be if I had a problem like this. Let's say we had 2x to the third plus 3x squared plus 5x. And let's say it was raised to the third power. Okay, so you technically could multiply what's in the parentheses 3 times by distributing on steroids, and it would go back to the addition rule. Or you could make it a little simpler. So if I were to do the derivative, the very first thing I'm going to do is this 3 comes down front, and I subtract 1 from that. Is that good so far? The next thing is whatever you have in parentheses stays as is for right now. But then this is raised then to the second power. Okay? And then what you what you have to do is you have to take the derivative of the inside, and that goes at the end. So the derivative, bring this down, minus 1, bring this down, minus 1, and this is x to the first, bring that down, minus 1. So that's going to give me 6x squared plus 3x, or 6x, excuse me, plus 5. So this is the derivative of the whole thing, and you don't necessarily have to go and multiply that out. It's just you have to kind of start doing it by little sections at a time. So the power rule, you bring the outside derivative down to the front, subtract 1 from it, keep what was in the parentheses as is, and then be sure you lower it. So this is the same above. This is 1 less than it was, and this was the derivative of the inside. Okay? Does that kind of make sense? I have to look at my book because I always get the order of them wrong. Yeah, it is cold in here. I'm freezing.
So what's that word?
Original with an L at the end. Okay, so that's the power rule. So that if you have something in parentheses and it's raised to a power, bring that power down front, being you're doing the derivative, bring the what's in the parentheses down, the original, but be sure you had lowered the exponent by 1, and then take the derivative of the inside. And again, these are all kind of real goofy things. This will allow you to find, anytime you take the derivative, it will allow you to find the instantaneous slope of a tangent line anywhere on it where you'd have to plug x back in, which that would be really super ugly to plug x back in. And where they make calculus so hard, and I always question why they make it so hard. If you had this problem given in calculus and you wanted to find the line tangent, they're going to give you like at x equals 5/12. So all of a sudden you have to plug 5/12 in. And what I always struggle with on calculus is like, why are you making it so difficult for the arithmetic? And the answer is always, oh, you have to be good at arithmetic to do calculus. I was like, yes, but there's a reason why students often won't take calculus is because they make the arithmetic so entirely difficult that it's not enjoyable. But if you make the, even if you had something like this, I would say, hey, what is the slope of the tangent at x equals 1, where 1 is really simple to plug in to the problem, but they give it a really obscure fractions to plug in. And I don't like it. It's not nice. And I remember when I taught International Baccalaureate and I was teaching the calculus, I just remember when the first problem, it's like they gave like 5/17 as the fraction to plug in. It's like, well, are you testing if the kid knows how to do calculus, or are you testing if the kid is really good at fractions? Because I feel in calculus you should test the calculus. Yes, arithmetic is arithmetic, but let's say someone didn't do so well at arithmetic. So let's say somebody had chickenpox in 4th grade when you introduced fractions, and that person with chickenpox missed 2 weeks. That was me. And that kind of stunk. Now, I was able to kind of recoup it because my mom was also a math teacher, so she could help me with it. But all the other stuff kind of stunk because... Can I move on? Okay. Then there's something called the product rule. Okay, and the product rule takes place when you have a problem that might be like this. So if you have two terms together, now you could FOIL this together and take the derivative as just like the addition rule. Or you could realize there's two parts to this. So what you do on this, let me make sure I say it the right way because I'm going to make it wrong. Okay, so you're going to take, you have two parts to this. So this is going to be just written like this. And then I take the derivative of the second part, which would just give me 2x. And then I plus, and I take whatever this is and multiply by the derivative of the first. And then clean it up a little bit. Say, okay, that's going to be, if Stirp could add and multiply. And then combine like terms, so I get 9x squared plus 4x minus 21. So this is the derivative of the whole thing. And you'd get the exact same derivative if you FOILed it all together, but where the product rule becomes handy is, let's say the two things in parentheses were not just two terms each. They were like 4 terms each. 4 terms multiplying out. There's an awful lot to get, a lot of busy work to deal with on that. So you got to worry about that. We're just taking some general notes on this. I'll give you a sheet of paper, and I can go back because when I get done, I'll go back to any screen you want to read. Keep that with your book. Okay, and then product means that we're multiplying two things together. That's why it's called the product rule. And we talked about the other day the quotient rule. And the quotient rule is when we are dividing two binomials with each other. So they're just general rules. They always work. The big pain when they give any of these is they would say that the product rule, you would have u and v, and it would be u derivative v plus v derivative u. And there's a lot of times where you're first time you've ever seen u and v used as a variable, and it gets a little goofy. And the thing is, the amount of things that you could do with the derivative, like you remember sine, cosine, and tangent. Sine, cosine, and tangent, they also have derivatives, but they become basically things that you have to memorize as far as, like the derivative of sine is negative cosine, but the derivative of cosine is sine. And there's things that you just have to kind of remember. If you go through it, it becomes a memorization process, which that has its own problems in that thing, because the whole concept of memorization is you eliminate a large amount of your population because of memorization. And it's not because if you have a hard time memorizing things, it doesn't mean that you're broken. It just means that your mind isn't wired that way. So unfortunately, a lot of times in calculus, they will say, okay, we have all of these things that have to be memorized, and all of a sudden, like 30% of the population will say, I have to drop the class because I have the hardest time memorizing. Okay, I am only a fair memorizer, meaning I feel like I have to work 3 times as hard to memorize things as somebody else. Doesn't mean I can't. It's just that I just have to spend so much more time. When I was going through a lot of this stuff, I was actually creating flashcards to get things so I could get them down. But there would be some students where they'd see it, 2 times and they had it memorized, and there would be me. I would walk around with flashcards around campus going, okay, this, yep, okay, this, yep, and that's how I did it. And it doesn't mean that, I was broken. I am a slower memorizer. It doesn't mean that there was something wrong with me. Well, maybe not. There's other things I'm sure wrong with me, but not everything. And then there's the quotient rule. And we talked about this a little bit last time. And this is when we are dividing two things. So if we had f of x is equal to 3x squared plus 2x over 5x to the third plus 7x. Because it's a division of fractions, that becomes a goofy thing to actually go through. And so we're going to call this top, and we'll call this bottom. Does that make sense? Top, bottom. I could say u and v, but that doesn't help. I like top and bottom. So if I do the derivative of this, it's basically going to be the bottom times the derivative of the top, we'll call that top prime, minus the top times the derivative of the bottom, all over the bottom squared. And that becomes the whole thing. So if I do this with the given problem, that's an f and x. If I do this with the given problem, move that down a little bit. We're going to go to the bottom, which is 5x to the third plus 7x, times the derivative of the top. The derivative of the top is going to be 6x plus 2. And then we're going to subtract the top times the bottom derivative, which is going to give me 15x squared plus 7, all divided by the bottom quantity squared. And this becomes a really ugly thing, because if you go and clean that up, you might have done the derivative correctly, but the algebra of foiling is going to goof things up. The biggest mistake that takes place here, as far as this class goes, I think I'm okay if you leave it like this. Where this gets goofed up is because you had a subtraction there. So you have to make sure when you FOIL this portion over here, you had distributed a negative throughout and then combined like terms. Again, it becomes one of those things where it's like the calculus portion is not difficult to do. In this case is where the algebra starts getting goofy. And if the algebra gets goofy, then the arithmetic might get goofy. And it becomes this whole problem. I mean, all my years I've taught, I've always wanted to try one thing. I always wanted to start out with freshmen in Algebra 1 and take that same group of kids, have them all 4 years, and get them through calculus. And they will never let me do it. At any of the schools I've ever been at, I've never been allowed to do it. And they're like, well, kids would just get used to you. I'm like, so what? They're going to know math. I'm like, most students that take Algebra 1 as a freshman will never get the opportunity to take calculus. And to me, it's like, if I kept the same 30 kids that I started in Algebra 1, I could get those same 30 kids through calculus by the time they're seniors, which could become a scheduling nightmare. But it's like, well, what's really important? Do you want kids to really have a good foundation and learn, or do you want them to take different teachers where those different teachers have different personalities, and those different personalities you have to get used to? And, you know, teacher freshman year had said a term different than teacher sophomore, junior year, or any of those mixes ups. You know, and the hard thing is, and this is kind of your financial literacy piece on this, the further you can get in math, you know, whether it's in high school and in college, the more financial stability that person will have being able to have calculus, because you're thinking at a higher level mathematically. It's not that when you walk out of the classroom into the real world, you're not going to be sitting there going, oh, the derivative of this is this. You're not doing that. It's because the development of calculus that you got in your head allows you to problem solve at something different. Meaning, you know, it used to be, I used to call it talk show intelligence, where you would have somebody who would watch some talk show and that they would feel that was the gospel truth, and the rest of society that was a little smarter realized it's mainly entertainment with you watching watching a talk show. Now it's coming down to, oh, I saw a meme that fits into my narrative, therefore it's the truth, and you try and spread your truth to others, even though you just saw a meme that was kind of funny. And you guys are all subjected to it. But, you know, and I'm not saying you're broken because that way, I'm just trying to give you guys don't really watch talk shows. You know, you might watch, I don't know, what's the binge-worthy shows on TV, whether it's on a streaming network, on regular TV. What do you guys watch? I know that my oldest daughter, who's in grad school, she loves that show 90 Day Fiancé. And every time she comes back, that's all that she has on TV. It's like, hey, what do you watch? 90 Day Fiancé. I'm out of here. Okay, but she's watching it just to, you know, be a brain dead thing versus not. So, so the quotient rule, the product rule is when you're multiplying two things together. The power rule, when you have a power outside of the exponent. And then the thing is, the power rule and the quotient rule, or the power rule and the product rule, can all be used with each other to solve things. So if you had some sort of mighty, really ugly type of thing, if you had something like this, and I'm not going to work through it, but if I had like, let's say I had something like this, well, you have to realize that the product rule the power rule has to take place here, and then once that takes place, then we have to deal with the quotient rule here, and so you can interchange them. Now, all of these could be done using just algebra, but it becomes kind of tougher to deal with. If you were to do this problem algebraically, actually, let me come up with one simpler because I'm going to bore the living daylights out of you more than I'm boring you right now. if I had like this, this could be done as the power rule with the quotient rule, or I could clean this up and say, okay, well, I know on top I have this, because it's squared, it's raised to the second power. And then if I FOIL this out, then I'm going to get to this. And then I'm going to get to this. And I haven't even done any of the calculus yet. Okay, so this is the algebra, being that this moved up to be this portion here, and then I could go ahead and take the derivative of that, and it's going to work out the same way, where that's going to be 2x. That should have been a 49, sorry. Minus 14, that's gone. This becomes minus x to the minus 2. And that's gone. And so then this cleans up to be this. So this is the derivative. But the hard thing is if I were to work that entire thing out, doing the power rule, then the quotient rule, it's, if I go and work out the real nasty, ugly, where I had right here, oops. If I were to work all this out, this actually would work out to something very simple like that last answer. But unfortunately, sometimes it's, they try and turn it into something way more difficult than it really is. And that's basically the foundation of math. And I don't know why the world of math wants to make things so difficult, but they do. And again, it's not that you're broken. It's almost like they're trying to weed out portions of society and prevent them from going further and further. And I don't know if it's like some government conspiracy to keep people not calculus literate, but, and I'm being somewhat facetious on that, but I mean, there's definitely things that I saw when I was in calculus, especially the amount of things that had to be memorized. It wasn't good. And I will strongly encourage each and every one of you to do this. If you go and you are on to college, you choose to go to college, if your degree requires you to take calculus, don't veer away from it, but don't take calculus at your university. Go over to the community college that's in the area and take the calculus there. You're going to get the exact same education, but you're going to be in a classroom of this size with a teacher like me, whereas if you were to take it at a university, you might walk into a class with 500 people in the same class, and the person is speaking so fast or so unclearly that you can't follow a doggone thing. And I mean, it really frustrated me seeing the number of students that I thought they should have been in calculus with me drop calculus and change what their degree was going to be, because the math that they made it so stinking hard that no one could comprehend. And that saddened me, because I mean, I was just too stubborn to ever say, no, I'm not going to do it. I mean, my big pivotal role was made it through my junior year for mechanical engineering, and then was basically told by my physics professor that I was a TA for, that I wasn't an engineer, I need to go become a teacher. And that's what I had done. But again, these types of things, if I were to take, as I said, if I were to take a class of 30 freshmen in Algebra 1 and be their teacher all 4 years of high school, I could get each and every one of those students through calculus and take the AP calculus exam and score a passing score of a 3, 4, or 5. I feel very confident that I could do that. But it just becomes one of those things where no, you can't do that. Why not? Well, because we've never done it before. Well, just because we've never done it before doesn't mean we can't do it. So those become kind of frustrating things. Okay, so everyone knows what tomorrow holds. You go to the theater. You don't check in with me. You just go right to the theater. Like, I'll be standing outside my door. If you come showing up, I'll be like, go to the theater. Unless you're not a senior, then it's like, okay, I'll check in with me, and you can go to the library, or you can just chill in here. It's up to you. And I'm not sure what that presentation is. Obviously, school felt it was a good presentation that they felt that the entire student body should go and see. I believe it's on cell phone use, I believe, but who knows? Who knows? I know that these days they'll say that, oh, students are off task because they're on cell phones. Well, guess what? Before we had cell phones, students were off task then as well. They used to pass notes. It was more fun when they used to pass notes, because if you'd intercept a note or you find a note in class, we got some good gossip. Now it's against the law that I go and follow students on social media and things like that, because I like going back to the notes, because it's like, ooh, Billy has a crush on Jenny. This is awesome. But Billy's afraid to ask Jenny out. Oh! So, yeah, I don't get that benefit anymore. I did have some good notes. Nothing too bad. They're good. Yeah. Yeah, I'll pull it